Now let's observe that if we had a circle of radius r about the origin, and a point x, y is in the circle, if and only if x squared plus y squared equals r squared, this being the equation of the circle and the expression of what the distance formula tells us, we could write this, if we wanted to, as x squared over r squared plus y squared over r squared equals 1. Now it's not maybe clear yet why we might want to do that, but we could certainly do that. So that if we have x squared over some number plus y squared over some number equals 1, that tells us that we've got the equation of a circle and that the radius of the circle is the square root of that common number under the x squared and the y squared terms. If we want to draw an ellipse, now let me back up and explain how we've drawn this ellipse. Okay, we could have drawn the circle inside of a rectangle, right? Just draw a rectangle from negative r, 0 to r, 0, and from 0 negative r to 0 r, and a circle is going to fit perfectly within that rectangle. If we want an ellipse, what we need to do is we need to stretch the circle out, perhaps in both directions, stretching it maybe more in one direction than the other. If we stretch it the same in both directions, we're still going to have a circle. To get an ellipse that's not a circle, and of course a circle is an ellipse, we're not going to get into all those distinctions right now, but you should be aware of them already. If we're going to get an ellipse, then we could do that by drawing a rectangle and then sketching the ellipse within the rectangle. Now the rectangle, if the ellipse is going to be centered at the origin, is going to have to come out the same distance here as it does from here to here, and then the vertical distance up is going to be the same as the vertical distance down from the center. And we're going to let those distances be a for the horizontal and b for the vertical, so that we come out to the point a0 and over to the point negative a0, up to the point 0b, down to the point 0 negative b. This corresponds to stretching the circle. Let's say we started with a circle of radius 1. If we stretch the circle by factor a in the x direction and by factor b in the y direction, then we're going to end up with this ellipse. At least I'm claiming that this is what we end up with, and we can and will prove a lot of this. We can prove it all, but we'll maybe not prove it all, we'll prove most of it. Okay? So, remember that the equation of a circle of radius r is x squared over r squared plus y squared over r squared equals 1. What should the equation of this ellipse be? Well, in effect, we have one radius in the x direction and another radius in the y direction. Now, those aren't really radii, but we can think of them as something analogous to distorted radii. We have one distortion of the radius here, another distortion of the radius here. So the effective radius in the x direction is a, and in the y direction it's b. As a result, we write the equation. Instead of x squared over r squared plus y squared over r squared equals 1, we write x squared over a squared plus y squared over b squared equals 1. And we think of a as being the x radius and b as being something like a y radius. But we got that in quotes because it's not really a radius. Okay? So this is the equation of this ellipse, the ellipse that fills this box. Now we'll go into more detail, and we've already seen, of course, what the equation for an ellipse is. When we first derived the ellipse, remember that we put the equation into the form x squared over a squared plus y squared over b squared equals 1. What happened to my square in this b? It looks like it was never there. Okay, it's a bad looking square, but at least we got one. Let's make a couple of notes. First of all, if y equals 0, then this term is 0, and x squared over a squared equals 1, which means that x squared has to equal a squared, which means that x had better either be equal to a or it's negative, so that when you square x, you get a squared, and when you divide x squared by a squared, you get 1. Okay? And here are the details of that solution. We get x equals plus or minus a. And this gives us the 2 points a0 and negative a0, and that's consistent with the picture that we just saw, where the points at the extreme right and left of the circle were a0 and negative a0. Maybe we ought to take a look back at the picture and make sure that we see that. Okay, right here is a0, right here is negative a0. So that the fact that these 2 points are on the ellipse is completely consistent with this equation. Now note that we also have the points 0b and 0 negative b. Those occur when x equals 0. Well, if x equals 0, in a very similar way, we're going to get y equals plus or minus b. And you can work through the details of that, but you just let x equals 0 here. You have y squared over b squared equals 1. You solve that, and you get y equals plus or minus b, which gives us the points 0b and 0 negative b, as we saw in the picture.